What are the other things given? Other things given, you can say Ka Marine equations modifying factor Ka is given as, this is given 0.91, Kb is given as 0.85. Okay. So, you see, then what are the other thing given? Reliability factor Kc is given as 50% reliability, means Kc is equal to 1. Now, Kd is temperature modifying factor is not considered here. So, this should be 1. Then stress concentration factor due to what it is called welding is given as modified, that means based on modifying stress concentration factor, this Ke is given as 0.772, and as the load is bending types of load. So, Kg is given as 1. This is very well known to us. Okay. So, everything is given. Now, based on this thing, first and foremost things what we need to do, we need to first find out endurance strength. So, that endurance strength how we can find out? So, based on Marine equation, what are the things we know? Endurance strength AC is equal to, you know, Ka, Kb, Kc, Kd, Ke, Kg into 0.5 into S ultimate stress. So, all of we are very well known about this equation, because I have discussed this thing in multiple time. So, based on this equation, generally what we need to find out? We need to find out this what it is called endurance strength value, that I am going to show. So, here Ka is given as 0.9 on surface finish factor, Kb is given as size factor is 0.85, Kc is 1, Kd is 1, Ke is 0.772, Kg is also 1 and 0.5, and ultimate stress is given as, ultimate strength is given as 860 MPa. So, this will give us a value of AC which is actually equal to, directly I am putting this thing, this value is equal to your 255.85, 255.85 MPa. Okay. This is the endurance strength we find out. Okay. Now, we need to find out what is the, what is called mean stress value and what is the amplitude stress value of this spring once it is subjected to a fluctuating types of load plus 75 Newton and plus 150 Newton. This you should keep it. How to find out this thing, that I am just going to calculate. So, here one things you can observe that here first of all, from this fixed point to this loading point, the distance is given as 500 mm. This is 500 mm. Okay. So, for that generally what should be the maximum bending moment in this what it is called fixed position, and what is the minimum bending moment in this fixed position, that I need to calculate. So, we know bending moment. So, first of all maximum bending moment will be, you can write as force into maximum force into distance from fixed end to loading point, because generally the bending in case of cantilever beam, you know bending moment diagram and shear force diagram. In case of cantilever beam, the maximum bending moment is used to come where the fixed end is there. This you should keep it, because moment equal to force into distance. So, fixed point to your point load location, this is the maximum distance. So, moment is independent of geometry, this you should keep it. It depends on magnitude of force and distance between what it is called position where we want to find out the bending moment, that position to loading point distance. Okay, that is the perpendicular distance we need to consider. So, here P max into you can say distance L. So, here L is given as you can say 500 mm. So, this will give us maximum bending moment will be you can say 150 into 500 mm. This will give us a value of, directly I am just putting this thing, 75000 Newton millimeter. Bending moment unit is like this. What should be the minimum bending moment for this cantilever beam? That also we need to find out. That will be your minimum load into distance. So, minimum load is 75 into 500. Thus, this will give us a value of 37500 Newton millimeter. This you should keep it in mind. Now, what is what is called mean bending stress? So, mean bending stress, let us consider this mean bending stress. We know MB maximum plus MB minimum divided by 2. So, this will give us a value after calculation. I am just directly putting this thing 56250 Newton millimeter. This you should keep it in mind. Okay. Now, what is the bending moment amplitude? This also we need to know. This bending moment amplitude will be MB max minus MB mean divided by 2. So, this will give us a value of 18750 Newton millimeter. Now, based on this mean bending stress, mean bending moment and amplitude of bending moment, what we need to find out? We need to find out what is what is called mean bending stress and what is the you can say amplitude of that bending. So, mean bending stress will be you can say MB mean into y. Here y is what? From neutral axis to outer peripheral distance. So, here generally as the diameter is 10 millimeter. So, let us consider this is our neutral axis. So, from neutral axis to outer peripheral distance will be actually r, that is your 5 millimeter. This you should keep it in mind. So, MB here r will be generally r divided by I. So, here what is MB? MB is already find out these things 56250 and your r is the distance from neutral axis to outer furthest distance, that is actually your 5 mm, and I generally here it will be pi d to the power 4 of this spring divided by 64. We know these things. Okay. So, after putting this d equal to 10, what we will get? We will get this sigma m equal to, you can write as directly, I am just putting this thing, that is 572 72 point you can say 96 Newton per mm square. This is sigma mean, okay, mean value I have find out. So, what is the sigma amplitude, that also we need to find out. So, for finding out this amplitude I am going to next slide, that will be better. So, the amplitude of this bending stress, so the bending stress amplitude will be you can say mv amplitude into r divided by I, that will be you can say directly you can write mb a into r divided by I is pi d to the power 4 divided by 64, you know these things, okay. So, I am not going further detail about all these things. So, after putting the value of all the things, mb amplitude, r is equal to 5, okay, r is equal to 5, d is equal to 10, okay, here d equal to 10. These are the things you should keep it in mind. So, after putting all these value, what are the things we will get? We will get generally this amplitude bending stress of bending stress amplitude will be 190.99 you can say Newton per mm square, okay. Now, what we need to do? We need to now draw the modified, what it is called. First we will draw the modified Goodman diagram and we will check whatever the mean bending stress and whatever the what it is called amplitude of this bending stress we get, this point where it is lying, that we will check, okay. After that, based on these things we will find out what is the life of this component, okay. So, first of all we need to draw the modified Goodman diagram. So, for modified Goodman diagram, this I am drawing here. So, this is our you can say mean, this is our amplitude. So, first of all we need to draw Goodman diagram or Goodman line. So, Goodman line actually this line is, let us consider AB, endurance strength to ultimate strength, this is straight line, and yield line generally now we need to draw the yield line. SYT, this will be our SYT, okay. So, this is our yield line, okay. Now, this two line, let us consider this is B, AB, this is C, let this is our D, this is crossing at a point, let us consider P. So, modified Goodman diagram is, we know these things, this modified Goodman diagram is, here I am writing, let this is our origin O. So, O, A, P, D, this zone is actually safe zone, that is modified Goodman diagram, okay. Now, in this diagram what we will do, we will plot the that you can say sigma B mean value and sigma b amplitude value. This we will plot to find this will this is actually the x point, you can say. This x point we will find by putting this two value. Okay. So, here sigma b m is given as, what is the sigma b m? Sigma b m is given already I have calculated, that is actually we got as, directly I am just writing here 7572.96 MPa, and this sigma b amplitude we got as 190.99, which is actually given here, already I have calculated and shown these things. Okay. This point I need to plot in this modified Goodman diagram. So, once I will plot the things, here you see this yield stress is given as how much? Here yield stress is given as generally 690, 690, okay, and ultimate stress is given as 860. Okay. Now, I am plotting this, I am plotting this x point. So, x point once I will plot, what I will get? This endurance strength, how much endurance strength we got? Little bit here I am putting, then it will be more clear to you. This value is 255.85, 255.85. Okay. Okay. Once now, once I will plot these things, we will get, let us consider from here to here, and after that some point we are getting. So, this is our x point, which have a value of 572.96.190.99. Okay, this point. So, it is observed that this x point which is lying outside the modified Goodman diagram. So, this point is generally is not safe, you can say, based on this modified Goodman diagram. So, for this, if it is not safe, then also it can be subjected to some what it is called number of cycle. What should be the number of cycle? That means, if the point lying inside the what is called inside the you can say modified Goodman diagram, then what happens, we can say it will not fail due to infinite number of these types of cycle. But if the point lying outside this modified Goodman diagram, then what happens, it will not be safe, but it can subjected to some number of cycle. So, how to find out that minimum number of cycle it can be subjected to, that is another step we need to discuss now. Okay. For that, what are the things required to do? For finding out that things, what generally we used to follow, that I am going to discuss. So, for finding out that things, first of all, generally what we need to do? We need to first draw this point B to x, draw this point B to x. After that, this we need to extend. What we need to do? This we need to extend along the same direction of that line Bx. This line where it is cutting with this ordinate, this point represent the whatever the stress value P1, let us consider P1, we will get that P1 will give us the, you can say, fatigue strength value of that component. What I am telling, understand? That will give us the fatigue strength value of that component. How I am doing? So, first of all, what we need to do? We need to join from point B, that is from the ultimate strength point to this x point. After that we need to extend along the same direction of that line Bx, and after extending this line cut the ordinate at a point, let us consider P1. At this P1, whatever the stress amplitude will get, that stress amplitude will give us the fatigue strength value of that component. This you should keep it in mind. So, for finding out the life of this component, first of all what we need to do? We need to first find what is the fatigue strength SF. So, we need to find out what is SF of this component, because if the point lying outside the Goodman diagram, then how to solve this problem, that I am going to show. So, this SF we need to find out. How we can find out SF? So, for finding out SF, you can say we can take two different triangle. What are the two different triangle we can take? So, let us consider this is X, this point represent M, okay. This point represent M. So, I am using different color, that will be better. This point who is cutting with the abscissa, that point is, let us consider M. So, to find out the SF, what we need to do? So, for finding out this SF value, we will consider what? Similarity of two triangle. What are the similarity of two triangle? So, one triangle I am representing as triangle XMB, or you can say BXM, this is one triangle, and another triangle is the bigger triangle, that is your B, P1 and O, B, P1 and O, this bigger triangle. So, these two triangles generally we will take. So, from this similarity of these two triangle, what we can write? We can write, you can say P1O divided by, that means base by base ratio, the perpendicular by is equal to perpendicular by perpendicular ratio, as because these two triangle are like, you see, you can see these two triangle are like this. So, this is one triangle, this is another triangle. So, if these two triangle are there, so this by this ratio, this divided by this ratio, you can say, okay. So, that thing generally here we are doing. So, here P1O divided by XM is equal to OB divided by, you can say, MB. So, this way, this we can write, correct. From the similarity of this two triangle, we can write this. So, P1O, what is P1O? This P1O is actually, you can say, we consider this, let us consider fatigue strength SF. What is XM? So, XM is given, XM is generally here how much it is given? Already it is given as 190.99. So, 190.99 is equal to, you can say, what is OB? So, OB is given as ultimate strength 860 divided by MB is given as how much? MB is given as ultimate minus yield. MB equal to your SYT minus you can say 572, whatever the 572.96, 572.96, correct, because M point has a value which is already given in this X point. This you should keep it in mind. Okay. Now, so what are the things we will get? So, SUT is given already, SUT is given. So, 860 divided by 860 minus 572.96. So, from here only one unknown is there. So, SF you can easily find out. So, SF what we are getting, this SF we are getting as directly, I am just putting these things. What is the SF value we are getting? Just this value we need to calculate. So, here SF value is 572 point, this value is 26 Newton per mm square. This you should keep it in mind. So, this fatigue strength now is calculated. Now, once this fatigue strength is calculated, now how we will find out what it is called number of cycle. So, for finding out number of cycle, now we need to draw what it is called SN curve. So, from this SN curve generally we will find out what is the value of number of cycle due to this fatigue strength SF. So, now I am going to draw this what it is called SN curve. So, SF already we have find out at 572.26 Newton per mm square. This you should keep it in mind. Now, we know for drawing SN curve what are the steps we used to follow, we already have idea. Generally this horizontal axis represent log 10 number of cycle and this vertical axis represent log 10 SF. Now, here generally the for drawing the what is called SN curve, first of all we need to consider a point A. Let us consider this point is you can say 3 comma, you know these things, log 10.9 into S ultimate strength, you know these things, I have already explained these things very clearly. And another point B we need to define, that B is 6 comma log 10 S endurance strength, which I have already calculated. So, we know log 10.9 into S ultimate, that is log 10.9 into 860, this will give us a value of 2.8887. So, 2.8887 I am just directly putting. So, then log 10 endurance strength we know 255.85, this will give us a value of 2.408. Okay. And whatever the SF we calculate, log 10 SF, this will give us log 10 572.26, this will give us a value 2.7576. Okay. So, based on these things we need to draw a straight line AB, this AB straight line we draw. Always you should keep it in mind, this is 3, this is 6. Okay. Now, we need to find out corresponding to this SF. So, SF is given. So, log 10 SF, corresponding to this SF we need to draw a horizontal line. This horizontal line cut this line AB at a point. From that point we need to draw a vertical line parallel to this what it is called coordinate and it is got the abscissa at a point. Let us consider this point give us the number of cycle log 10 n. This we should keep it in mind. This should be log 10 n. Now, let us consider this is A B. I am drawing this thing, that this is our C, this is our D, this is our E point. Now, here also we will use a similarity of two triangle, similarity of triangles. What are the triangles? AED and triangles ACB. Based on these two triangle, what are the things we need to find out? We need to find out this log 10 n, that I am going to find out. So, from the similarity of two triangle, what are the things we can write? AC divided by AE is equal to, you can say, CB divided by you can say ED. Okay. This you should keep it in mind. So, what is AC? AC we can write as AC already we have already find out this thing. AC means you can say log 10.9 ultimate, log 10.9 ultimate is 2.8887. C is your endurance strength value, this is our what? Log 10 endurance strength, log 10 AC. So, this log 10 AC is given as 2.408 divided by what is AE? AE is given as 2.8887 minus log SF is already given 2.7576. Okay. This will be equal to CB. What is CB? CB is, you can say, CB is actually 6 minus 3 and ED is, what is ED? ED you can write as log 10 n minus 3. This you should keep it in mind. Okay. Because this point is 3, this is not 0, that is why we need to put it like this. So, from here we can easily calculate the number of cycles. So, this number of cycle generally here we will get 6579.34 number of cycle. Okay. So, here the number of fatigue cycle for these types of fluctuating axial load. Okay. Generally it can, this spring can sustain this many number of cycle. So, this is the design cycle you can say for this spring. So, this way generally you can find out the life cycle of the of a structural component, or the life cycle if it is given, then what should be its dimension, that also we can calculate. Or let us consider this spring we need to design for infinite number of cycle, then generally according to factor of safety and what it is called crossing point of this load line with Goodman diagram, generally from their detailed step I have already discussed. Based on that thing generally we can find out for infinite cycle what should be its dimension. Let us for a number, particular number of cycle, what should be its dimension, that also we can find out. So, this all about modified Goodman diagram subjected to bending types of loading. Similar things generally or similar types of design steps we use for axial types of loading case also. that means fluctuating axial types of loading case also. But for torsional case we use separate modified Goodman diagram. So, next class I will discuss about fluctuating types of torsional case. Once a structural component subjected to fluctuating types of torsional types of shear stresses, then what should be the design procedure and how to find out the dimension of that structural component, as well as how to find out the number of cycle if the dimension and other thing given. Then for a particular loading condition what should be its fatigue life, that also we can calculate. That related thing in details next lecture I will discuss. So, these are the references which I have followed for this lecture. Thank you.